Right, so an electron is accelerated, so we know that it does have that, it must have force that F net cannot equal 0 since it's accelerating. From an initial speed of 1 times 10 to the 7 meters per second by a potential difference of 1.7 times 10 to the 3 volts. And then enters a magnetic field of 2.5 or 0.25 Tesla, moving perpendicular to it. What is the magnitude of the electric or the magnetic force acting on the electron? So let's write down everything that we know. So for this question, I like to make sure that my speed for V looks different than my big V for volts. So I kind of make my little v cursive so that it's a little bit different. And my magnetic field is B 2.5 times 10 to the negative 1 Tesla. And I am looking for Fm. All right, so we're going to have to kind of do a couple steps. So let's make a map of what we're going to do here. So if Fm is equal to Q times V perpendicular, well, I have, what I need to do is, this is, well, we should actually put it here, this is V initial. I need to find out its velocity as it's in the magnetic field. So it's like I need to find V final. Okay, so it's initially coming in at that speed, and then I need to find my final. So what I need to do is I'm going to have to find V from V final here. Well, how can I do that? Well, I'm going to use my EK equals half mv squared idea of kinetic energy and how the electron is changing in its kinetic energy. So if I expand that to say, well, delta E, if I'm just looking at delta EK, that's EK final minus EK initial. So if I need to solve for EK final so that I can find V final, then I'm going to rearrange this for EK final is equal to delta E plus EKI. Now, if I want to find, oh, did I skip a step here to show you guys? To get this, I'm going to have to use my delta V is equal to delta E over Q. And then I can put that into this formula to solve for EKF and get VF, and then put it into this. So there's quite a few steps involved in this one. Well, not a lot, it's just not a lot of formulas you actually have to put in, but so the first thing that we'll do is this, okay? We'll do our delta V equals delta E over Q to solve for delta E, okay? Then what we'll do is we'll find EKF, okay? Then we'll find VF from that EK, and then we can put it into here. So those will be our steps. So the first thing, delta V is equal to delta E over Q. So if we rearrange, delta E is equal to delta V times by Q, which is 1.7 times 10 to the 3 volts multiplied by the charge of an electron is 1.6 times 10 to the negative 19 coulombs. So my delta E is 2.72 times 10 to the negative 16 joules. Okay, so now, I think my second one, yeah. So now my second thing, I have my delta E is equal to EKF minus EKI. So I'm going to rearrange to solve for EKF is equal to delta E plus EKI. So if I expand that, I have my delta E plus half mvi squared. So now I can plug in my information, what I have. So my delta E was 2.72 times 10 to the negative 16 joules plus half times by 9.11 times 10 to the negative 31 times by 1.0 times 10 to the 7, and that value needs to be squared. So now my EKF is 3.1755 times 10 to the negative 16 joules. So that was my second step. So now I can move on to my third. So if EKF is equal to half mVF squared, VF needs to be the square root of 2 EKF divided by M. So if I plug that in, 3.1755 times 10 to the negative 16 joules, all divided by my mass, 9.11 times 10 to the negative, did I put in the wrong thing here? Yeah, no, negative 31 kilograms. So VF is 2.64 times 10. I got negative 24. Negative 12? Negative 24? Here?
No, I got positive. I have 2.64, but it's doing positive.
That's weird.
Let's just leave it.
Okay, well, you know what? I'll finish this, but what you need to start doing is the question B ones.